Okay, so here's my plan. I pulled up just a bunch of sample problems. You just give me the thumbs up or thumbs down if you want to talk about it or not.
Yeah.
Okay, so these are just, I mean, there's a lot of variation in these, but these are essentially the kinds of things that are going to show up on both of the tests, right? So what about something like this? If we're given a graph and we're asked about finding limits, evaluating the function and finding limits. So they want to know, like, what do you think?
Maze.
Maze? You okay on this one?
Can I ask a question?
Yeah. Yeah.
If you have finding limit of it says f(x) equals something, and then they put 2 in front of it, you just multiply it through, right?
Yeah.
They'll tell you how much, like, what the limit approaches at x.
Right. Okay, there's one coming up like that. When we get to that one, we'll talk about it. But you're right. That's it. Yeah. So we're okay on this one, probably? Okay. This kind of stuff, where we're evaluating limits, where we're approaching an asymptote from one side or the other. Right? You want to take a quick look at this or not? Give me thumbs up if you're good on this, thumbs down if you want to talk about it. We'll go through one of these? Okay, that's fine, we can do that. So on these, like, what about this first guy here? If we're gonna take the limit of -2 over, and it's all x minus 1 to the 5th on the bottom and -2 on the top. If we're approaching this, we're approaching 1 from the right, what's this gonna give us? So we know that if I let x go to 1, the bottom goes to 0, right? I get a number divided by 0, which means what? Infinite. Okay, so we know we're getting infinite. The question is just what kind, right? So we have to just evaluate the sign of this. If x is approaching 1 from the right, what is x minus 1 going to? Small positive, right? So this is the same thing as saying 0 plus to the 5th, which is positive or negative? Positive. So we get an answer of -2 over 0 plus. The 0 on the bottom gives us the infinity. Negative over positive is negative. Okay? What about here? If we do the same limit, only this time we're approaching 1 from the left. So does everybody agree this time we're going to get an answer like -2 divided by 0 minus to the 5th? So 0 minus to the 5th is still negative, right? So we're just going to still have 0 minus. Everybody agree? Okay. And so that's going to be positive infinity. And so as a consequence then, can we say anything about this? As x approaches 1, the two-sided limit, can we say that we get an answer of either positive or negative infinity? Can't, right? Because we got different answers. When we approached from the right, we got negative infinity. When we approached from the left, we got positive infinity. And so there isn't any consistent behavior on this one. So this is an example. I think we talked about one of these on Friday, maybe? I think we did. So this is an example where it does not exist, and it's neither positive nor negative infinity. Now, what if this had been like a 6th power on the bottom? If it had been even, then in both cases we would have gotten 0 plus on the bottom. Everybody agree? Then both of these limits would have been negative infinity, and so we could have said, yeah, it's negative infinity. Still doesn't exist, but at least we know that from both sides it's approaching negative infinity. Everybody see that? Yeah. Because these two disagree, we can't even say that much. Okay? Question? So all we're saying is that because this one approached...
The two limits equal each other? Like they're the same? Like you're saying?
Right, because they're not this time, we can't say anything consistent, right? This time the answer is it doesn't exist and it's neither positive nor negative infinity. But if they had both been, let's say, negative infinity, then the limit still doesn't exist, but we could have said that the limit is negative infinity. Right, the two-sided limit. When I just say I approach 1, we're not being specific. That means from both directions, right? Do we get a consistent answer? Go ahead, Kate, go ahead, read.
No, like if they're the same, we should put that.
Yeah, yeah, but you see why though, right?
Yes.
Yeah.
Wait, how? If they're the same, put that, they're not.
No,
But-
but you
but-
just said that there wasn't a
Sorry,
limit,
but
but
I
a limit.
meant-
Well, okay, right, I mean, it's, infinity's not a, isn't, I mean, that's still no limit, right? Infinity's not a number. So when we say something like this up here, that the limit, this, look at part A. When we say that this limit is equal to negative infinity, does that mean there is a limit? No. There's no limit, but we can be specific about it. We're saying it goes to negative infinity, which is useful, right? It's still, it's like if we said, does that limit exist? No, it doesn't, because it goes,
Oh,
you get the idea?
yeah.
So you gotta be careful with the term, and I understand how that can get confusing. So down here at the bottom, we would still say, like, if these matched up, we would say, well, yeah, the answer is negative infinity. Does that mean that the limit exists? No. It means we got an answer, right? So in that sense, you could say, yeah, there's an answer to this limit. So it seems like it exists, but you gotta be careful in math. Exists means it approaches a finite value, right? Where the ant could say, think how we talked about it from the very beginning of the year. As x approaches 1, could the ant say, I anticipate stepping on this number? Well, no. He's going to be going up to negative infinity or down to, right, see what I'm saying? Okay, we clear on that? Okay. More of the same, really. It's just a little bit trickier. I want to look at maybe just one of these, how about? We have to look at all of them. As x approaches 2 from the right, what's going to happen? What are we going to get here? On the bottom, I'm going to get a 0 plus squared. Everybody agree? Okay, so 0 plus. What about the top? All I need to worry about is just that first term. Agreed? Okay, so the first term is going to be what? Positive, right? We could factor the top, and we've talked about that too. If we factor the top would factor into x minus 5 and x minus 1, right? Now as x approaches 2, doesn't really matter from which direction, I'm just going to get a negative times a negative, right? Is that right? It's 2 minus 5, oh, what the heck? What just happened here? Did I factor that right? Yeah, I did. Yeah. So, what am I doing wrong here?
Wait,
Four
you mentioned
minus
the first
12
one, so
plus
you
5,
first, the other
that's
four would
negative.
subtract this, you'd be less than 0 on top. Because it would be 4 minus 12 plus 5.
Yeah. All right, okay, so I was gonna tell you something wrong here, the first time. So you can't just go by, we can't just go by the leading term here. We have to actually factor it. We have to look at the signs of the factors. Okay, and it is gonna make a difference. And that's how we did it before. Right, so when we take this function, if I wanna take the limit, because we gotta follow the sine rules. So if we have the limit of x squared minus 6x plus 5 over x minus 2 squared, as x approaches 2 from the right, I've got to break this into, I've got to factor the top and factor the bottom, right? On the top, I'm going to get, we already did this, we're going to get x minus 5 over x minus 1. On the bottom, we get x minus 2 squared. Now we can assign signs to all these. So when I try to evaluate this, I get on the top, 2 minus 5 is negative 3, right? On the bottom, and we could literally just, we could just plug 2 into the top and just evaluate it too, right? We're going to get an actual number on the top. It's the bottom we have to be concerned about. The bottom is the one where we get this weird zero behavior, right? The top is not, nothing's weird about the top. We can evaluate that part directly. Whether we factor it or not, we should get the same answer. We get -3 here, and we get +1 there. And on the bottom, we said we got 0 plus squared. So what's that equal to? -3 over 0 plus. And so the 0 on the bottom means infinity. And then if we look at the signs of the top and the bottom, negative over positive is negative, right? So we're getting negative infinity, okay? We could just directly evaluate the top too. You don't actually have to factor it. It makes this determining the sign easier to do if you have really big numbers in there. But if I were just gonna, this is what you did, I think, Kirk, right? You just plugged in 2, and you got 4 minus 12 is -8 plus 5, there's your -3, right? We can evaluate that part directly, but it's the bottom part that's weird. That's where you've got to say to yourself, okay, well, I'm approaching 0, but is it going to be a 0 plus or a 0 minus? Okay, so what about this? What about this part right here? The top doesn't change, right? If I evaluate the top, I'm getting, what was -3, right? And on the bottom, this time as x approaches 2 from the left, I'm getting a 0 minus squared. So what's that mean? 0 plus. So once again, there's our negative infinity. Okay, now Maisie, what's the answer going to be down here? If we take the two-sided limit, it's going to be negative infinity. Does the limit exist? No. But at least we know that it's negative infinity, right? We know that when the ant approaches -2 from either side, it's plunging down towards negative infinity, right? Okay? Is everybody clear? I feel like I've kind of started to get you messed up. Is everyone okay with that?
Yes.
Okay.
I have a quick question.
Yep.
0 over a number, that means that it's 0?
0 divided by a non-zero number is just 0.
Okay.
Yeah. Okay, more of the same. Okay, but if we try to do this one, if we try to evaluate this directly, what are we going to get? 0 over 0, right? So if it's 0 over 0, that means we got to do more work, right? What's the more work going to look like here? You got to factor the top, factor the bottom, cancel like factors, right? So what does the top factor into? If I've got a sum of cubes, I want you to remind me here, what is the pattern for a cubed plus b cubed? In fact, let's do a cubed plus or minus b cubed.
A plus or minus b.
So if it's plus, it's plus, minus, it's minus.
Times a squared minus plus ab plus b squared.
Right. Okay. That's, I mean, that's a useful one. It's been a while. I would say that's a useful one to know. There's, the two that are useful to know would be this one, and then, now, I'm gonna show you a way you can do this without remembering that too, okay? And you could just divide this out synthetically, for example. Okay, but I think that's a good one to know. What about a squared plus or minus b squared? What's that one equal to? Hang on. What's a squared minus b squared? Sorry. We don't have a plus. That doesn't matter. A squared minus b squared. That one's pretty easy. What's that? Okay. Those three are the three that are pretty useful. Okay. And I know it's been a while since you guys have done this, but it'll come back. I mean, you're going to do this enough that without even really trying, it'll come back to you. So how could we do this? So factoring, let's finish it using this factoring method. So this would equal the limit of x plus 4 times what? So a is x, b is 4, right? I've got a cubed plus b cubed. So x squared, 4x. Yeah. Everybody see that? So if A is 4, A is x, B is 4, we get, there's our x plus 4 times x squared minus x times 4, which is 4x, plus 4 squared. Okay? Divided by x plus 4 as x approaches negative 4. And you can see that the x plus 4's would cancel, right? And so then we're trading this function for a new function that fills in that hole, which we can evaluate directly. Now if we let x go to negative 4, we're just getting negative 4 squared minus 4 times negative 4 plus 16, which is what? 16, so 16? Would you agree? No, sorry, 48? Yeah. I saw those quizzical looks, I knew I'd mess something up. Okay, you could also do this though with synthetic division. Right, we could just say on the top, what would the coefficients be if I'm gonna divide this through synthetically? And we can do it because the bottom's linear, right? So what would the coefficients be? Right, and there's our remainder. And then what's the 0 of the bottom? So that goes out front, right? Drop that down. Negative 4 times 1 is negative 4. We add. Negative 4 times negative 4 is 16. We add. Negative 4 times 16, negative 64. So there's no remainder. And what do you know? That's what we got. Right there. Okay, make sense? Okay. Okay, what about this? Kirk, this is one of the ones like similar to what you were just talking about, right? So if we know that the limit of p of x divided by q of x as x approaches 0 is 8, and q of 0 equals 4, find p of 0. Okay, this is just properties of limit stuff. This is not intended to be, there's very little math here, just trying to recognize what's going on. So the limit, here's the important step. The limit of p of x over q of x as x approaches 0, here's the property of limits. We can take the limit of the top divided by the limit of the bottom. We can separate those. So I'm just going to get, if I evaluate these directly, just getting that, right? And think how we evaluate limits, like when we do stuff like, if I were to take the limit of 3x squared minus 2 over 2x as x approaches 1, what's the first thing you try to do? Just plug it in, evaluate directly, right? And if we did, we'd get 3 minus 2 is 1 over 2, and that would be our answer, correct? Moral of the story, we can calculate the limit of the top and the bottom separately. The only time we have a problem is if they're both 0, right? But the limit of p of x over q of x as x approaches 0 would just be evaluate the top and evaluate the bottom and see what you get. So they're telling us that this is equal to 8. They also tell us that q of 0 equals 4. Well, how could we solve for p of 0? Yeah, I could just either solve for p of 0 up here, or even just substitute first, right? So that's going to tell me that q of 0 equals 4. So now I would just multiply both sides by 4 and I get 32, right? Okay, good? All right, how about this? Plug it in. See if it works. So 5 times 4 is 20. 16 minus 12 is 4. Square root of 4 is done.
So if you can plug it in and just get a number, that's it.
absolutely. We always want to try that first. Kind of, if you go way back to the start of the year, think what we talked about, when you evaluate limits, you're always going to try to evaluate directly. Three possible things could happen. You're going to get a number, done. You get a number divided by 0, which means it's infinite. And then at the time, we just said no limit. Now we can go a step further and we can do something like this, right? And we can say, okay, well, if it's a number divided by 0, we could say, okay, what if we approach that value from the left and the right? What happens? And we can be descriptive and say, okay, it's asymptotic, but is it approaching positive or negative infinity? Right? And if both answers are the same, then we can be descriptive even about the two-sided limit. Okay? And then the third possibility was something like that, where we get 0 over 0, and then we have to do some algebra to resolve the indeterminacy, right? To figure out what it actually is. More work, aka more work. Okay, how about this? So this is one where you just have to, you're going to have to kind of, if you get this one, you got to think about what a cosecant function looks like, right? And you might have to just create it for yourself. I always do. So cosecant is what? 1 over sine. Okay, so this is like saying the limit of 1 over sine x as x approaches pi from the left. So we don't even really have to use the graph here, do we? We could do the same thing we just did before with this, right? If we'll look at the graph too, but you wouldn't have to. If I take this limit, I get 1 divided by, now what's this going to be on the bottom? If we're approaching pi from the left, negative pi. So if we're approaching negative pi from the left, what's that going to be a number like? Like, I mean, it's a little bigger than pi, right? So it's going to be like a negative pi plus a smidge. Okay? What's the sign going to be like there? Now, there's a couple ways you can think about this. You could think about this in terms of a unit circle, which is probably what I would do. But it's not the only or even necessarily the best way. If I'm going to negative pi, that means I'm going to move around the unit circle. There's negative pi. There's a little bit more than negative pi, right? In other words, slightly less than negative pi. So sine is the y component, agreed? So if we look at the coordinates of that point right there, well, the x-coordinate's about 1, isn't it? Negative 1. What's the y-coordinate? 0 plus. And that's the one that we care about, isn't it? Right? So we get 1 over 0 plus, which is what? Positive infinity. Okay, how could you do that on the graph? If we were to graph, so let's see, there's pi, negative pi, negative 2 pi, 0. What is we got to kind of think back to pre-calculus. What is our trig? What does a cosecant graph look like? So cosecant is 1 over sine. Where is sine equal to 1? Pi over 2. Okay, so at pi over 2, it's going to equal 1, right? At 0, it's going to be, we're going to be dividing by 0, right? Sine of 0 is 0, sine of pi is 0. So we know we're getting asymptotes like that. And remember this, right? So then what's it going to be over here? Well, doesn't it just jump down and do that? Right, because 3/2 pi, sine of 3/2 pi would be negative 1, right? Do you agree? If I jump back here, sine of negative pi halves is negative 1. So I'm getting sine of negative 3/2 pi is positive 1. Okay, so where are we then? Where are we on this graph? If an ant is walking towards negative pi from the left, isn't the ant clear up there? Positive infinity? Either way. Okay. Make sense? Any questions on that? Okay. What about one like this? What do I try first? Okay, try to evaluate directly. If I do that, what do I get? 0 over 0, right? So what's my recipe for eliminating that indeterminacy if we've got radicals in there? What do we always do? Multiply by a conjugate. Good, so we're going to take the limit of the square root of 2h plus 1 minus 1 over h times. Well, here is the portion of the fraction that has the radical in it, right? It's still going to 0, so that's the one we want to take the conjugate of. Everybody see that's the conjugate? Of course, you wouldn't change the sign inside the radical, right? It's the sign between the radical and the constant. Or it could even be two radicals. You got to change the sign between the two terms, right? And then what are we going to get? Limit. On the top, this is just an example of a minus b times a plus b. Well, that's just the reverse of what we just talked about. Just a squared minus b squared, right? So on the top, we're just going to get, what's a squared? If that's a, I get 2h plus 1, which, and all that is the square root of 2h plus 1 squared, right? Minus 1, which is just 1 squared. Okay, that's fine. Then on the bottom, we get this whole mess, right? That's okay though, it's just gonna be, I know it looks terrible, but just think into the future, when we let h go to 0, that's not gonna be a big deal to evaluate, right? So on the bottom, we have h times the quantity, square root of 2h plus 1 plus 1. So now, what's happening that's important? Bottom, we're kind of stuck with something ugly, but what's happening on the top? The ones cancel, right? When we combine like terms, we're just getting the limit of 2h over h times quantity 2h, square root of 2h plus 1 plus 1. And now we can cancel those factors, right? And just evaluate the limit. So as h goes to 0, now what do we get? Well, at the top we're getting 2. On the bottom, what's the square root of 2h plus 1 as h goes? What do we get? The h is canceled, so we just get 2 on the top. On the bottom, this is going to be 2 times 0 plus 1. So square root of 1 is 2. I mean 1, right? Plus 1 is 2. Everybody see that? So we just get 1. Okay? How about this? Maybe.
No, I'm pretty sure.
Yeah, it is actually.
Yeah.
You're right. No, you got it. How'd you, no, you're right. How'd you get it though? You can't disregard the science. This is one where, and you can kind of get to a point where, I mean, and that's good. You start to kind of see the patterns, you get some intuition about this stuff. But how could you, like later on in the year, when we're, I might have you guys prove it, right? Like when we're preparing for open-ended questions, I want you to prove this one. But this proof isn't that big a deal. Yes, sir?
Did we prove says sine b squared over b squared is 1? Like that? Is it equal or no?
No, you can't. You can't quite do it that way. But here's what I'll remind you of. What's our special limit involving sines? Okay, so we have the limit, I'm going to call it theta, sine theta over theta, as theta approaches 0 equals 1, right? So we're trying to get, I know what you're saying, it's an interesting thought, but that doesn't quite work, if I understood what you're saying.
I think that just said the same thing, like
Oh, I got you, never mind, okay. Okay, you're right, so where's the t-squared? Just a random thing? Okay. So this is, I was thinking you were doing something different, I'm sorry about that. So this is the one we want to go back to, we want to write it in the simplest form, right? But our goal is to see if we can have this limit popping out in this statement up here, this expression, right? So we got two different signs. When I have sine 8x and sine 5x, I'm stuck with those. It's really inconvenient to change the angles in trig functions. You might remember that from last year. Those are some awful trig identities. Right? I mean, you remember that stuff if you want to do the half angle formula, double angle formula. And then 8x is even, so you'd have some success with it, but 5x would be terrible. You have to make that a combination of like 3x and 2x, and the 3x would be x plus 2. It'd be just a mess. You don't even want to start thinking about it. So all we want to do here is we want to see if we can set this up where I can match the 8x up with its theta and the 5x up with its theta, right? So how about this? The limit of sine 8x over something times sine 5x. Now what needs to go there? 8x, right? What needs to go there? 5x. Because obviously if the sine of theta over theta goes to 1, then it's reciprocal with 2, right? Reciprocal of 1 is just 1. And so I need to get an 8x here. Well, how can I get an 8x on the bottom? I can't just multiply the bottom of something by 8x. I gotta multiply both top and bottom by 8x, right? So if I multiply an 8x there and an 8x there, now that's fine. I haven't changed anything. I've multiplied by 1, right? Over here I could multiply by 5x over 5x, right? Now that looks pretty good. I'm starting to see the stuff that I need. Look, there's sine theta over theta. There's a theta over sine theta, right? Yes, sir.
So what did you put 8x?
What did I just do here? No, that's good. Never mind. Go ahead.
So the first one had 8x out front, and the other one had 1.
Would have a 1 over 5x out front. Okay, so now what if I just rearrange these things? You can probably see where this is going. Good, the 8x over 5x, the x's cancel, right? So I'm going to write that out. So we got it. Tell you what we'll do. I'd be willing to put this off until Wednesday if you want to finish going through all these problems like I said.
Yeah.
Is that good?
Yeah.
Okay, all right.
That's good, Chief. I just read something online.
Okay, but Wednesday's it. Right.
I just read something online that says in 12 years, basically, our world is going to die.
Sure.
Because of climate change. We're going to be above like 1.5 degrees Celsius or something.
It's-
above something.
I don't think we're all gonna die, but I
know
do.
it's gonna